My name is Ravi Jain. I'm founder of InnoSepra LLC based in New Jersey. This is a company that's developing technology for CO2 capture from power plants with the aim to utilize the CO2 for enhanced oil recovery application. We are also developing technology for biogas purification and power plant pollutant controlled. I have a PhD in chemical engineering from the University of Michigan. After that, I worked for the BOC Group, which was the last industrial gas company at the time when I worked at BOC Group. I invented, developed, and commercialized 25 technologies in gas purification and production, and then utilizing some of that experience base to develop technology for CO2 capture and power plants pollutant control.
All right, and you gave a presentation today that talked about a project that you have in Delaware. Can you tell us a little bit about that?
Yeah, so a few years ago, we were developing CO2 capture technology in the lab. We went and talked to the Department of Energy. We put in for a solicitation, and we got a project on demonstrating our CO2 capture technology at bench scale. We also talked to Energy, whether they would be able to participate and provide the host site for the demonstration, and Energy agreed. We're using Energy's plant in the Indian River, Delaware, to demonstrate our technology. And the testing is mostly completed. We started in May of this year, and we hope to finish the testing third quarter of this year. The scale of testing is 1 ton per day, so we take a small amount of flue gas from the Energy plant, run it through our process, and then we recombine the captured CO2 and the balance of flue gas and send it back to the stack.
All right, and you see if this test is successful that you could develop this further and possibly retrofit plants throughout the country?
Right now there is no regulatory driver for capturing CO2, so only economic driver for capturing CO2 is using CO2 for enhanced oil recovery, which limits the applicability of technology to the plant that are close to either oil or gas fields, mostly in Gulf region, some in other states as well. But yes, if you can produce that market is there for taking. Only thing that you really need is a CO2 at a cost which is acceptable to the industry, and also the purity that would be needed to send the CO2 through the pipelines into the oil and gas fields. We believe, based on the testing we have done so far, we believe we are on the path to meet that cost and purity target, but before we can get to that market, we need to develop it, do at least one more scale up of our technology to 2 to 5 megawatt scale, and that will be large enough to build the CO2 capture plant in 1,000 tons per day or bigger, and which the CO2 from those plants could be used in actual oil fields for enhanced oil recovery.
All right, and you also see this as a worldwide possibility, correct?
One of the things when we were doing technology development, one of the things that we did was we also found a solution that can not only capture CO2 from power plant, but also capture SOx and mercury from the flue gas. So one of the things about our technology is that it does not require any flue gas cleanup. So most of the other technologies, such as amine-based absorption, require a very deep cleanup of the flue gas in terms of SOx and NOx. We can take the raw flue gas, run it through a pre-treatment system to remove SOx and mercury, and then capture CO2. So what we found is, because there is a large overlap between our technology and the SOx and mercury removal technology, you could envision a scenario where you build a system where you capture only SOx and mercury first, and then add CO2 capture later on if there is either a regulatory driver or some other economic drivers such as enhanced oil recovery. So for countries like India and China and other countries which have a significant air pollution problem because of the coal-based power plant, they could utilize the solution, the first part of the solution, which is to remove SOx and mercury, and later on if they can add CO2 capture for essentially 25% of the cost of an MEA-based CO2 capture. So you can have best of both worlds. You can meet the current needs and then also future-proof your power plants to add CO2 capture in the future if needed.
Okay. Thank you very much for your time. I appreciate it. This is Aaron Larson for Power Magazine from the Mega Symposium.